Welcome back to this lecture series on deep learning. In this lecture, we'll see why we should learn machine learning for implementing deep learning algorithms. Machine learning is essential because in modern computing techniques, this machine learning technique is very, very important because it enables systems to learn patterns and make decisions from data without requiring specific instructions for every task. Unlike a traditional programming where explicit rules must be written, machine learning models can automatically adopt by analyzing data, which is particularly useful in environments where problems are too complex or data is too vast to handle manually. So that only we are going for the that is machine learning techniques. This machine learning techniques is used in many applications. The first one is the predictive modeling. In predictive modeling, machine learning algorithms are trained to forecast future outcomes based on historical data. Prediction means what? Something we are going to predict if the rain is coming or not. So we are going to forecast the future things, future outcomes based on the historical data. This approach is valuable to businesses as it allows them to anticipate customer needs or market trends. For instance, companies can predict which customers are likely to make a purchase or churn, while healthcare systems can use machine learning models to identify patients at a higher risk of developing diseases. The next application is the natural language processing. This natural language processing which allows computers to understand, interpret, and respond to human language. And applications of NLP include voice recognition systems like Siri or Google Assistants. Everyone is using the Siri or Alexa or Google Assistants, customer support chatbots, and automated translation tools, all of which rely on machine learning to improve their linguistic understanding over time. Next application is the computer vision. In computer vision, machine learning is used to interpret visual data such as images and videos. That is, in this case, ML models can be trained to detect objects, recognize faces, and understand scenes, making them essential in fields like automation, autonomous driving, medical imaging, diagnostics, and security surveillance. Next, fraud detection, the application of another application of MLS. Machine learning algorithms are effective in fraud detections as they can learn the typical patterns of user behavior and identify anomalies. In finance and e-commerce, ML is used to detect suspicious transactions or advertising fraud by flagging actions that deviate from normal behavior. Next, recommendation system. In this application, how this machine learning is used means it is powered, the recommendation systems are powered by machine learning, help tailor content or product suggestion to individual users based on their past behavior. For example, if you are taking platforms like Netflix and Amazon, use machine learning models to analyze user preferences and suggest movies or products that the user is most likely to engage with, enhancing personalization. Next, overall, the machine learning is a transformative technology that helps organizations process vast data sets, uncover insights, and automate decision making. In applications span across industries, improving productivity, user experiences, and strategic forecasting through data driven approaches. Next, and the workflow of ML, everything is available in my the previous lectures. If you want to learn in a detail, you can visit my previous lectures. And here, the definition of machine learning is it is a specialized field within artificial intelligence that involves designing systems that can identify patterns and relationship in data. These models do not need explicit programming for each task. Instead, they learn from examples and generalize to make predictions on new unseen data. Here the workflow is given by the first one is the forward pass. It is the initial step in the learning workflow where the machine learning models processes the input data to produce their predicted output. The model uses its current set of parameters, weight or biases to compute the predictions, which is then compared against the actual value to evaluate performances. Next, loss function, that all you know that this loss function is also referred to as the cost or error function, measures the differences between the model's predicted output and the actual output. It quantifies how well or poorly the model is performing. The goal during training is to minimize this loss by refining the model's internal parameters. Next, model optimization process. In this case, how it is being used is it involves adjusting the model parameters iteratively to reduce loss functions. This is typically done using optimization algorithms such as gradient descent, which calculates how changes in each parameter affect the loss. By following the direction of the negative gradient, what it will do is the model incrementally improves its accuracy with each iteration. Next, once the model has been trained on the data set and optimized, it becomes capable of making predictions on new data. The quality of these predictions is evaluated using the performance metrics like accuracy, precision, recall. These are all we have seen it in the previous lectures. And F1 score, which helps determine how reliable and generalizable the model is in practice. Next, the gradient descent algorithm. This also we have seen it. It is used to find out the loss functions. This we have seen and we have discussed in the previous lecture in detail. The iterative method, it is minimized to loss function. Error function is the gradient descent function. This is the delta nu is equal to delta old minus eta into dou loss divided by dou deta. This deta represents what? Learning rate. Dou loss dou deta is the gradient, and it is continuously updating. If you're not been getting the targeted output again and again, we have to update this weight parameters, and it continuously updating the parameters until the loss function is being reduced. Till it gets a 0, we are going to update the process, and it helps in improve the model prediction accuracy with the each iterations. Next, another the machine learning life cycle, and we have to how we are going to use it. First, we have to study the problem. That means we have to understand the domain goals and define the ML objectives. The machine learning life cycle consists of the systematic step required to build, train, and deploy a machine learning model. These steps ensure the development of robust models that can solve real world problems essentially. The first step is we have to collect the data. Data collection is very important. First, we have to study the problem. This initial phase involves understanding the problem domain and identifying the specific objectives that the machine learning model needs to achieve. This step defines the scope and expected outcome of ML project, aligning it with business or research goals. The next step is the data collection. Once the problem is understood, the relevant data is gathered from multiple sources such as databases or sensors or APIs or web scraping. The quantity and quality of data collected play a crucial role in determining the effectiveness of the machine learning model. This is very important. Data collection model is next. Data preparation. In this, the first step is data cleaning. It is performed to remove the inaccuracies such as the missing values, duplicate entries, and outliers. Clean data is essential to avoid misleading patterns and ensure the model learn from reliable inputs. Next, data transformation. In this case, the transformation involves normalizing or encoding data so that it is in the form of suitable for the chosen algorithm. For example, converting categorical variable into numerical form using one-hot encoding helps in model interpretation. Next, feature engineering. It helps into exploring data analysis and using the feature engineering. During this subset, statistical requirements, statistical techniques and visualizations are used to understand the data pattern. Feature engineering involves creating new input variables from raw data that can enhance the predictive power of model and the splitting the data set. In this case, the data set is split into training and testing subsets. The training data is used to learn model parameters, while the testing data is used to evaluate how well the model generalizes to new inputs. Next, model selection. This input involves choosing the most suitable algorithm based on the type of problem and data characteristics. And the knowledge of algorithm strengths, weaknesses, and assumption is necessary. Sometimes multiple models are compared and the best one is selected. Next, model building and training. In this case, for traditional machine learning, building the model requires a minimal setup, such as choosing an algorithm and adjusting few hyperparameters like tree depth or learning rate. Next, in this case, in the deep learning, the model building is more complex. One must define the architecture layer by layer, specify input output dimensions, and choose optimizers and loss functions. Training such can models can take longer due to their complexity. Next, model training, or that we can tuning. Once the model is defined, it is trained using the prepared data set. The algorithm iteratively updates its parameter to reduce error and improve accuracy. Next, we have to go for the model evaluation. In this case, after training the model, it is tested on the separate data set to determine how accuracy it can make predictions. And evaluation is done using metrics such as F1 score. This we have seen it in the previous lecture. Precision, recall, mean square error, and ROC curve, depending on whether the task is classification or regression. Next, model tuning. Based on the evaluation results, model hyperparameters are tuned to achieve better performance. Techniques such as grid search or random search are used to find the optimal configurations. Next, deployment. This step is also a very important step. Once the model performs satisfactorily, it is deployed to real world environment. This may involve integrating it into an existing software platform or building a new service that uses the model for real time predictions. Next, monitoring and maintenance. In the final stage, the deployed model is continuously monitored to ensure it remains accurate and effective. As new data becomes available or as data distribution changes, that is, data drift occur, the model may need to be retrained or updated. Next, so in this case, the next machine learning. The types of machine learning, this also we have seen it, three types: supervised, unsupervised, and reinforcement. Each type has different goals and use cases based on data availability and training methods. The first one is supervised. It uses the labeled data. That means known data, known input, known output. It learns from mapping function from input to output. There are two types in this case: regression and classification. It predicts the continuous values. That is linear. There are the algorithms used in this case is linear regression, ridge regression, and SVR, random forest. Examples of house prices, temperature predictions. If you want to know the detailed discussion that we have discussed in the previous lectures, that you can see. And classification, it predicts the categories or classes. And that there are algorithms used in this case is logistic regression, naive Bayes, decision tree, and SVM, KNN. And example, the main application of this case is spam detection, disease classification. Unsupervised, you know that it uses the unlabeled data, no predefined outputs, and it discovers hidden structure and grouping in data. And there are two types in this case: clustering and dimensionality reduction. The clustering means group the similar data points, and algorithms used in this cases k-mean, DB scan, hierarchical clustering, and the example is customer segmentation, gene expression analysis. Dimensionally reduction, it reduces the number of input variables. And the algorithms used in this case is PCA, TSNE, autoencoders, and the application is visualizations and feature compression. Next type is the reinforcement learning. Here the learning could be done via interactions with the environment. And the agent takes actions and receives rewards and penalties. And the goal is to learn a policy that maximizes the long-term reward. There are two types used in this case, model-based and model-free. Model-based, it learns the environment model, example, state transitions, and the algorithms used in this case is value iteration and policy iteration. Model-free reinforcement learning means it learns from direct experiences. Algorithms used in this case is Q-learning, SASA, deep Q neural network, that we can call it as DQN. DQN. Next, very important point is why we should learn machine learning for deep learning. So, deep learning is a subset of machine learning. All you know that it is a foundational machine concept directly. Here, the deep learning is not a separate field, but a part of machine learning. So, to understand deep learning well, one must first be familiar with the core concepts of machine learning because they form the base of which deep learning is built. The next one is machine learning introduces important ideas like how to measure a model error using loss functions, how to reduce that error using optimization techniques like gradient descent, and how to check if your model is performing well using evaluation metrics like accuracy and F1 score. Next one is understanding overfitting and underfitting. That means overfitting and underfitting are common problems in both machine learning and deep learning. Learning these concepts early helps in designing better model that do not memorize data or perform poorly. The bias variance trade-off explains how to build models complexity and prediction accuracy. The next one is machine learning. This teaches how to prepare raw data before feeding it into model. This includes cleaning, transforming features, selecting important variables, and dividing the data into training and test sets. Skills that are equally needed in deep learning. The next one is optimization. It One of the most important tool used in deep learning is the gradient descent, which is also taught in machine learning. Learning it early helps in understanding how deep learning models adjust their parameters during training. Next, machine learning helps you learn how to troubleshoot model errors, adjust model setting called hyperparameters, and understand what the model is doing. Skills that become even more important when working with complex deep learning models. Next one is the final one is here the ML builds a strong base for transitioning into complex architecture like CNN and RNN and transformers. By learning machine learning first, we can develop the basic thinking needed to understand and build advanced deep learning architectures like convolution neural networks and recurrent neural networks and transformers. So for these cases only, we should compulsorily learn machine learning techniques for implementing the deep learning concepts. Hope everyone understood the concepts of the basic needs of machine learning in order to implement the deep learning techniques or algorithms. The remaining things we'll discuss in detail in the next lecture. Thank you.